burning with the fire of the sun. The electric arc furnace renders molten steel. White, hot metal is extruded into enormous slabs. The rolling mill presses raw steel into high-strength armor plate. These are the bones of the most powerful warship known to man, a Nimitz-class aircraft carrier. It takes 7 years and over 30 million man-hours to build a Nimitz-class carrier. With a crew of nearly 6,000, the ship is a mobile airbase for 80 state-of-the-art warplanes. Fully loaded, she weighs 97,000 tons, nearly 200 million pounds. Her 4.5-acre flight deck is as long as the Empire State Building is tall, and could encompass 3 football fields. Construction of a Nimitz-class carrier represents the most complex shipbuilding challenge ever undertaken. Virginia's Newport News Shipbuilding Company has been at the vanguard of carrier design and construction for over 3/4 of a century. It is the only facility capable of building these mammoth warships. As of early 1998, 2 of these supercarriers were under construction. The Harry S. Truman was nearing completion, while the Ronald Reagan was at the start of its building cycle. The carrier begins its life as bits of data in a virtual world. Major portions of the carrier's structure and some of her more complex systems are created in the computer as solid, full-size, 3-dimensional models. The computer model accounts for every one of the millions of pieces of steel used in these assemblies.
With the 3D model, we can see the entire arrangement within a particular space. What we try to do is clean the design up, remove any fouls between structure and maybe pipe, make sure that the sailors on board have accessibility. They can read dials, they can get to places they need to without any conflict. We clean the design up long before we get to any manufacturing.
With the final design approved, it's time to build the carrier for real. Steel is cut according to plan, and the pieces are welded together to form basic structural units. These basic units are combined to form large modules called superlifts. The completed superlifts are lowered into the dry dock and joined together to form the ship. Of course, this is easier said than done.
I'm working on CVN 76, which is a Ronald Reagan aircraft carrier. It's new construction. We get little pieces called base A units from down the road, and it's just like putting a puzzle together. You get little pieces, you weld them together, you make bigger pieces, you weld those together and make bigger pieces. The bigger pieces are what I work on, which are the superlift units, and I'm in charge of the structural completion on the superlift units. This yellow mark right here is just, basically if the weld looks like it penetrates too far into the steel, you have to weld an undercut. So they'll just go back and they'll put another bead of weld there and grind it flush.
It takes a crew of 25, working in the various crafts or trades, more than 3 months to complete even one of these gigantic puzzle pieces.
We get light fixtures in, we put pipes in, we paint. We've got about 8 trades working together out here, and there's so many jobs that go on within the superlifts that you want to make sure the trades are working together and that they're not blocking each other out. So there's not painting going on where welding is supposed to be going on, things like that. When you got the T-bars in here, it's easier to weld all the T-bars straight down the vertical before you put the knuckle plate on, right?
Yes.
There's a lot more room to work in there.
Right. And then you can get some updraft in there too.
The coordination effort is staggering, not only because of the hundreds of subsystems in such an enormous ship, but because all the separately built pieces must eventually fit together seamlessly.
So once we make a superlift, it's 900 tons, we'll put it on a crane. Just like a part of the pyramid, you lift the enlarged portion, which is the superlift, down into the dry dock, where we combine all the other superlifts as more puzzle pieces to make what eventually will become the ship.
Spanning Dry Dock 12, the Krupp gantry is the largest crane in the Western Hemisphere, with a lifting capacity of 900 metric tons. The crane operator works the controls from a small bubble, 25 stories above the dry dock floor.
It's pretty exciting to come in knowing that you're operating one of the biggest cranes in the world and some of the things we do. I guess it's not for everybody being up here by yourself all day, but you just have to get in the mindset. And I guess I've been doing it about 22 years. I started off operating small stuff and worked my way on up. I guess I can't get much higher than this, really.
The crane's task on this day is the reorientation of this 730-ton hull section. It is often easier to build a superlift upside down or on its side, as is the case here. This unit is finished, ready to be lowered into the dry dock. But first, it must be turned upright.
All right. Coming up.
Shipyard veteran Bill Ballou supervises the heavy lift.
I've been employed by Newport News Shipbuilding for 38 years. I've been in the North Yard working these cranes for approximately 22 years. Every carrier that's been built at 12 docks, I've been involved in it from the beginning to when she set sail into the James River, and that's been, this will be our 4th aircraft carrier.
While smaller pieces can be turned by the crane alone, large superlifts must be rolled over in a giant sand pit. The immense size and weight of the superlift makes this a daunting task.
It looks good to me, Billy. Put her on the ground.
All right, bringing it down easy.
All right, Robert, put the axe on her. We'll hook her up on the other side.
The 9 crane cables are reattached to the actual topside of the unit.
Hey, get your twist out here, over here, baby. Twist out, Chili. You know how to do it. You gotta do it. Let me get on that. Get the twist out of it. Come on, baby. Twist it in the right push. There you go. Hey, chill up, forgot how to do it. You didn't jump there with an eye on the top. Be quiet, fighter. Get on. Get on all the ears so you can get on.
The crane takes up the slack. Like a waking giant, the superlift stirs.
She's digging in the pit right good, Dave.
The sand gives way under the mass of the superlift, preventing the bottom edge from being crushed by its own weight. Wooden blocks are positioned to catch the piece as it reaches its center of gravity. Without them, the superlift could tip too far, subjecting the crane to a potentially catastrophic shock load. It has taken almost 2 hours to reorient this superlift. It will take another 3 hours to move it to the dry dock and correctly position it against the ship's framework. In the machine shop, crews labor to complete the carrier's propeller shafts, which must be installed before the ship's engine room is covered over. This shaft section is 66 feet long, 2 feet in diameter, and weighs 52 tons. It will take 7 such pieces to make up just one of the carrier's 4 propeller shafts. The shaft is lowered into a giant lathe for final machining. The lathe can turn pieces up to 67 feet long and weighing up to 61 tons.
Well, this is a stern tube shaft for an aircraft carrier, and I'm machining the groove for the half collars.
In the dry dock, several of the completed shaft sections are scheduled to be installed. They'll have to wait. There's a problem with the Krupp 200-ton crane. A small electrical glitch in the control panel has crippled the massive machine. Specialists are brought in to correct the trouble.
0.4? 0.4? Is it 0.4 or 0.04?
You got one tight, right?
I got 2 tight.
Time is money. A major delay could seriously impact the construction schedule.
We have a circuit board problem that's not allowing the 2 hoist hooks to come up evenly at the same time, and we're trying to examine to find out what that problem is right now so we can load the shaft, and it's critical that both hoists rise and lower in sync with each other.
Down below, the crew continues their preparations, counting on a quick repair.
Basically what they're doing is they're trying a different method that they've never done before by installing these actually before they get everything covered up inside. They're going to pick both shafts up at one time and place them in the ship, which is all fairly new. I've never done all this.
After 2 hours of troubleshooting, the repair crew has solved the problem.
How did it feel when you came back to engine?
Good. It's like it went back to where it was.
Don't worry, we get out.
They've found the problem, they fixed it. We'll be going up with the shaft here in about 20 to 30 minutes. They're rigging it right now.
The sections are installed in pairs. 4 of these pairs will be bolted together to form one entire propeller shaft. The piece is gently lowered into the narrow confines of the engineering compartment. The completed shaft must be perfectly straight in order to turn properly. Precise alignment is critical. 12 high-strength steel bolts join the sections. The joints must be able to withstand the force of the 80,000 horsepower generated by each of the 4 engines. Were a joint to fail, the shaft would tear itself to pieces. A portable hydraulic super wrench finishes the job. Half a dozen separate sections are now one. Dozens of new superlifts have now been added. The carrier has grown to half its eventual height. Adjacent to the dry dock, the next round of superlifts is being built. Inside what will become a stern section, the after steering room is being constructed by students from the shipyard's apprentice school. For all its modern technology, the shipyard still values the centuries-old tradition of the apprentice. Young men and women work alongside master shipbuilders. The secrets of the trade are passed down to a new generation.
Normally we go to school in the morning. We have classes. We take a little bit of math, some English, and then we come back out here to work until 3:30.
Yeah, I enjoy it because I used to sail on the ships, so it's kind of interesting to see how they're built and actually be a part of building it.
I'm from Hampton, Virginia, and I got started here. My dad works here, and he opened up the idea to me. I know I didn't want to go to college right away, so this seemed like a good chance for me to get started in something.
Well, I'm from North Carolina, and I heard about it from uncles that have been here 40 years and some cousins, some brothers.
Oh, I love it. You know, you get to play with fire, you get to build something, you know, you can say, hey, I built that, you know, a couple of years. Really good opportunity, I like it.
12 weeks later, the stern section is complete. The 900-ton gantry is the only crane big enough to move it to the dry dock. From 17 stories above, the crane takes up the weight of the 1.5 million pound superlift. Below, the crew breaks loose the shores. Supporting the entire weight of this steel colossus, the crane struggles to haul it skyward. This is one of the heaviest lifts the 900-ton crane will have to handle. The forces involved are immense. The superlift must now be fitted to the ship, a process more ticklish than usual, as this unit must mate precisely with the two propeller shaft supports which have been pre-positioned on the dry dock floor. There are only 3 inches of clearance.
Hey, come there. Ain't no way you can move that pipe. So what we need to do, we need to get back west here, baby, so we can be able to come down. All right, give me a little bit more west there, Dave.
From 250 feet above, the crane operator inches the mammoth superlift into position. The superlift now hangs inches away from its final position. With the crane still supporting the weight, steamboat jacks are now attached at dozens of points. It is human muscle power that pulls the stern section into final alignment, 1 fraction of an inch at a time.
Touch it up a little bit. You got the other side on.
With the piece secured in place, an army of welders goes to work. Every mating surface, exterior hull, interior bulkheads, pipes, and electrical conduits are joined. The fire of the welder's torch finally bonds Superlift to ship. As the months pass, more pieces are added, 169 in all. The ship begins to take shape. With the outer hull complete, sea valves are opened. The dry dock floods and the giant ship rises off her keel blocks. Afloat for the very first time, she is towed from the dry dock to an outfitting pier, where everything from bunks and toilets to advanced combat systems are installed. One of the most important jobs remaining is the installation of her 4 catapults. These massive steam-powered pistons will literally shoot aircraft off the carrier, accelerating them to flight speed in under 3 seconds. The Harry S. Truman is less than a year from completion. On Truman's flight deck, shielded from the elements and spying eyes in the sky, a crew of 60 labors to install one of the 300-foot-long catapults.
Counterclockwise, ready, turn. Ready, turn.
31 hand-crank winches support a 170,000-pound catapult cylinder. Each synchronized turn incrementally lowers the cylinder.
We have to be so careful and keeping the torque and the load on each cable just exactly right, so that one cable breaks, it's just like a set of dominoes, they're all going down. And if these drop, start all over again, guys.
Ready, turn.
The Navy crew has begun to report on board. The future catapult crew labors side by side with shipyard workers, getting their first introduction to a system they must ultimately master.
That's great. Well, I think the first one that I worked on was the Nimitz, and I've worked on just about all of them up that, either in the overhauls or new construction. You get to build a system where you actually get to see work. And then, you know, you watch television and the news all over the world and you see aircraft being launched and you know that you were a part of that, you built the system, and it makes you have a great feeling and know that you're doing something which matters.
Six weeks later, the installation is complete. It's time to test the catapults.
What we're trying to do here today is establish the power curve with the different dead load weights, that we can relate that to aircraft, which allows them, when they know the weight of the plane, that they get every plane launched not too fast, not too slow.
Set 220 on 4.
This is the first time Truman's No. 4 catapult will be fired.
Here we go.
Roger, 458 clear.
3, 2, 1, fire!
That's great. That was a good shot.
Sleds of differing weights simulate various combat aircraft. The testing program goes on for 2 days. Each sled is launched at a number of different steam pressures and valve settings. If the sled goes off too slow, steam pressure is gradually increased until the proper launch speed for an aircraft of that weight is achieved.
This is Sergeant Briones, I guess. He's about to take a swim.
The seriousness of the testing program can't prevent the Navy crew from sending a symbolic message to an old rival.
Hi, I'm Tom Otterbein. I'm the CEO of America's newest nuclear-powered carrier, the Harry S. Truman. And my crew and I are trying to get ready for the Army-Navy game. We're making an effort to show the Navy Brigade of Midshipmen that the fleet supports their efforts.
And we've got our mule up here on top so that when it hits the water, it should explode pretty well. Well, it sure looks like the Army to me. The way he's sitting, his posture, you know, the tongue hanging out, buck teeth.
Stand by! From the flight deck of America's newest nuclear-powered aircraft carrier, the Harry S. Truman, to the Brigade of Midshipmen.
Go Navy / Army!
They had a little more speed than that, but that's good.
Yeah.
Woo!
Yeah, that was a slow roll.
That was a slow roll, but it worked.
All right, thanks a lot, guys.
Only 4 weeks remain before the Truman is scheduled to go to sea for the first time. On board, work reaches a fever pitch as construction crews race to deliver the ship on schedule.
All right, here we go.
Many of the ship's systems are just now coming online. As work continues, basic supplies begin to find their way on board. The Navy crew is moving in, even as shipyard workers put the final touches on Truman. The result is a chaotic struggle for space amid a tangle of construction equipment. One by one, as spaces are completed, they are turned over to the Navy.
It's basically a mess. We're trying to make it, neat so that when the Navy comes, they come through, decide that they want it, or we have to fix what they don't like.
When the deadline gets closer, everything gets a little more hectic. Maybe looking a lot faster, more people, around you because everybody's trying to get their stuff done.
The work must be finished before Truman embarks on builder's trials, the first phase of a strenuous series of at-sea operational tests. Sea trials will be the culmination of the new ship's construction odyssey. Two weeks before departure, reactor officer Andy Pitts and his team bring the ship's nuclear power plant online. The reactor spaces and engine room are classified areas. Only crew members with high-level security clearances are allowed access. The energy produced by the two nuclear reactors drives the engines, heats the living quarters, cooks the food, generates electrical power for the weapon systems, and provides high-pressure steam for the catapults. The reactors can power the ship for more than 20 years before needing to be refueled.
Well, when you're getting ready for sea trials, it's 7 days a week, 24 hours a day. You don't have time to turn around. We're into the final phases of making it shine. We've got the last of the testing to go, and the painting and the cleaning to make his ship look presentable when we deliver it to the Navy and take it in on his first trial. So right now, if you stand still long, you're going to get painted. Yeah, this place is getting along real good. They're just putting down the electrical matting now. And this is going to be one of our big challenges here end of this week, next week. The ship's loading all the stores through here, and I got to get the deck blasted and the non-skid down, which is going to be a big challenge. Hello, Bernard. How we doing? You say you're looking here. Figured in 2 weeks we're going to be serving meals out of here. This is where the Admiral will be staying on sea trials. We're just getting the carpet in now. The furniture just showed up this week. It's got a little bit more to do in here. They're starting to put the wallpaper up on this. This has got the gold carpet in here. So the only problems we've seen so far on this new console has really been in this amp-off indication.
Truman is the first Nimitz-class carrier whose bridge features high-tech touchscreen navigation controls. The crew trains on the new system as they prepare for sea trials.
Well, you've been training, what, now, about a week on it? Now, if I'm not mistaken, you use a touchscreen, but if you go to GQ, you use the mouse because of the gloves.
Right, yep.
Okay.
And actually, these guys prefer using the mouse on the small stuff like the alarm system.
I could understand that. It's nice to see y'all up here and operating this thing. That just tells me we're ready to go to sea.
I can't wait.
I know it. Either can I.
Let's get this done.
2 weeks and we'll be ready to go.
Too long. It's time to get in the ball game.
That's right. It's terrible to keep steering around the roads and the buildings out there. It's time to get out there and steer around some real ships.
A helicopter touches down on the flight deck. This is the first aircraft to land on the new carrier. As tradition dictates, it is co-piloted by Truman's commanding officer, Captain Thomas G. Otterbein.
That's Chief. How are you? Welcome aboard, Skipper.
Captain Otterbein is no stranger to flight. A Navy pilot himself, he rose to command the prestigious Top Gun training school before becoming captain of the Truman.
Thanks, Bruce. Welcome aboard, Skipper. What are you out here for? You worried about me?
After 7 years of hard work, Truman stands ready to meet the sea.
This Harry Truman's going on builder's sea trials this morning. We've got approximately 30 riggers on the ship, untying the ship so that they can go to sea. I'm the rigger in charge of the cranes down here and cutting the ship loose. I want to tie these eyes, I want to coil that wire down across the road.
On the bridge, the captain and his crew complete their final checks.
How you doing, Chief?
Admiral Frank L. Bowman, a former submarine commander, is on hand to evaluate Truman's performance.
Is this his lambskin-covered chair here?
Pretty nice, wouldn't you say, Admiral?
My golly day, you don't have that on submarines, you know.
No, sir, you don't.
We're tough. Diesel oil and stuff.
It takes these 30 riggers 3 hours to get this ship ready to go to sea. A rigger's work is bull work.
Conning Officer, helm safety, read you loud and clear.
Read you loud, somewhat jumbled.
An armada of tugboats surrounds the Truman, holding her to the dock as the last lines are cast off.
What's the status on the disconnecting of phone lines?
Wait. ACD on the studio, we got a copy, disconnecting phone lines.
Nice, take a stand by, Mike.
Go on! Yeah, go! We're underway, tugs are working. She's all cut loose from the pier, ready to go to sea trials.
One by one, the tugs drop away. For the first time, the Truman is steaming under her own power. America's newest carrier heads for the open sea. ready to face her first great challenge. As Truman leaves the shipyard behind, builders' trials are in full swing.
I'm the engineer officer on board the Truman, in charge of just about everything that's not reactor or main propulsion oriented. The catapult system on the flight deck, the air conditioning and chill water system on board, aircraft elevators, the general announcing system that you hear here that's not working quite right. We're hearing a lot of cracks and squeals coming out of it, but troubleshooting's in progress. We're also going around in teams to physically operate every piece of gear that we own in all modes, both normal mode, emergency mode, and even some other backup modes to fully flex it, make sure that it's been built right and that it'll perform the way it's supposed to.
It's not a Delta faucet, but it's just
Any problems discovered are immediately repaired.
Which one?
I'll find out in a second. Report that switch. I gotta go through the...
I got 4 wires, I believe.
We have trades here from the electricians, pipe fitters, mechanics, fitters, anybody that we need to fix any binding problems or mechanical problems.
In the hangar bay, the emergency fire doors are tested.
If they have any fires or explosions on one side, they can close these doors and protect the aircraft that they've got on the other side. Right now, it's not closing far enough. We'll fix it.
She bounced back about an inch.
A proximity switch has been installed in the wrong position. It must be cut loose and moved 3/4 of an inch.
I've been doing this for 23 years. I've done 7 different carriers and 140 doors. I do doors. I don't do windows, I just do doors.
On the flight deck, the 4 catapults receive their final adjustments.
The catapult has to be final shim. When we built this initially, we set it a little bit wide, and the engineering department uses a formula to close up the slot so that you can operate in tropic temperatures or you can operate in Arctic temperatures, and your slot won't be too tight that the shuttle won't go down, and it won't be so loose that the shuttle will slap back and forth.
8,000 bolts must be removed. Hundreds of man-hours are required to complete the shimming process. It is so time-consuming that Truman's catapults will not be ready for final testing on this phase of her sea trials. Taking a brief leave from Dry Dock 12, Sandy Dugan tours completed spaces on the Truman, which correspond to those under construction on the Reagan.
You have to try and envision what a completed system is going to look like, and you have to envision how things are going to intersect and how things are going to go together. And when you get down here and you see how it's finished, you say, oh, now that makes sense. I understand why that pump was set this way or why we waited to do this. I can think of all the things that we did wrong when we installed that. We came in and we had the legs installed improperly. We had to go back and cut that loose and fix it. Both pumps for the aqueous firefighting foam, A-frame. I tell you what, it looks nothing like this right now out where I'm at.
One of the final tortures inflicted on Truman during builders' trials is an extended high-speed run, backwards. For 4 days, Truman has been subjected to every test her builders and crew could devise. It has been a strenuous time for all involved.
Sitting up on the bridge these last few days, it's been so exciting that I have not been able to go to sleep. In fact, I'm on my 40th hour with 2 hours of sleep. If I have many more exciting weeks like that, I'll be dead. But it really was a treat to watch the ship operate. Admiral Bowman, everybody had good things to say about the enthusiasm, professionalism, and just the quality of the people aboard the ship, so I'm really proud of that. Builders' Trials has gone well.
Go for the reactor.
Truman has returned home. Discrepancies found on builders' trials have been fixed. Now the second phase of sea trials begins. Acceptance trials are run by the Navy's Independent Board of Inspection, known as INSERV. Everything from safety equipment to the propulsion plant is tested for final certification. The stakes are high. Only after Truman passes this rigorous inspection will she be allowed to join the fleet.
We're sort of the outside expert that represents the Navy, separate from the shipyard and separate from the Naval Systems Command, which is heavily involved in the building of the ship. My team, because we inspect somewhere like 110 ships a year, has quite a bit of experience, and they know the sort of the problems that routinely occur. So a little over 120 people or 100 people come aboard the ship and put the ship through its paces to make sure that all the equipment works as it's supposed to.
We want to make sure that every safety system on the aircraft elevator works. We also make sure that general operation is like platform can reach from hangar deck to flight deck in 20 seconds. And we checking the motors on every switches, every gauge, every level. Any of the light is in, out, or in?
Light's not lit. We got light bar malfunction, light again.
I'll just write it down as a discrepancy. Don't worry about it. Okay, in the meantime, go ahead.
The other side look good.
Clear?
Look good. Clear?
Yeah.
They're making a thorough inspection. I just hope they can't find too much wrong with it.
Our mission here to make sure that that door gets closed in 20 seconds.
After a thorough check, the door passes inspection.
Oh, Newport News always building good ships. So far I never had any problem. I've been doing almost over 12 years, and this is my 8th or 9th carrier on Newport News shipbuilding. They do a good job.
We're getting the gear functioned for the in-serve inspection, and we're getting catapult shot and testing everything out, making sure everything works good. So far, so good. We have our little problems, but everything's going relatively well.
We can do one from deck edge, that'll work. Thank you.
All right.
And then we're gonna run water in the JBDs, right? 3?
Yes.
Then we're gonna check the time on 4s, lowering it?
Yes.
Okay. All right. Thank you.
Good enough?
Good enough, boss.
Thank you. Thank you.
Consistent anyway.
Very consistent.
On catapult number 1, Ron Jones and his team prepare for their final test.
We've shimmed this catapult, and actually, since we've shimmed it, we haven't fired it, okay? And you're always a little nervous when it happens that you don't get a tight spot in there, and with all these people here, all of a sudden it just, shuttle doesn't go down. So we think everything's fine, taking some slight gaps, but you always feel a little bit better after the shot, That's the final proof. What are you gonna do? Shoot one from the deck edge, one from the cab?
One from the bubble, one from deck edge. Probably one from below the panel.
Hey Frank, is that a quiet cat or what?
Good job.
You can have it. You hear that rickety piece of crap?
That's it. Speak louder, Bosun. You're on TV.
I heard rickety.
The new carrier now prepares for her ultimate challenge, a grueling series of high-speed turns. The 4 massive engines, generating over 250,000 horsepower, are brought up to full speed. Cruising at well over 30 knots, Truman's rudders will be thrown hard over. This violent maneuver will subject every part of the ship to incredible stresses. For Harry S. Truman, the moment of truth is at hand. Truman is steaming full ahead. While her top speed is classified, this 97,000-ton vessel is the fastest warship afloat.
All engines head full. 100 RPMs indicated as for, sir.
Very well.
Get ready, fellas.
With engines straining, the captain gives the order. The rudders are thrown hard over.
Right 35 degrees rudder.
Right 35 degrees rudder, aye, sir.
Well, right now we're testing our rudders to make sure that the rudders have enough power to turn the ship at the maximum rate of turn with speed on the ship, and you can see we're heeling way over. You can't see the horizon out through the other set of doors there because we're heeling over so much.
As Truman makes her wild turns, she heels at an angle of 15 degrees.
Oh my God! This is a good turn.
Counting officer, my rudders are right 35 degrees, no new course given, sir.
Left 35 degrees rudder.
Left 35 degrees rudder, aye, sir.
Again and again the order is given. Truman heels port, then starboard, cutting huge S-shaped swaths through the roiling sea.
Negative 12 degrees now.
Oh, for heaven's sakes!
We're going up on it. Right 30 degrees rudder.
Right 30 degrees rudder, aye, sir.
We want to thank you for your hospitality. You got a great crew, really. I mean,
Rear Admiral Lyons and his team are satisfied. Truman is judged worthy. In naval parlance, she has made a clean sweep.
keep it up. We're going to have our discrepancies. We always have discrepancies, but
well, you'd be out of a job if you
That's
didn't.
That's right. They get rid of me. Again, thanks for everything.
Thanks for being aboard, Admiral.
You know, we got to keep up the tradition here. This ship's really run fantastic. We're going to get the broom. We need to get permission to fly the broom.
We got the room right back here. We anticipate a good trial. Traditionally, you normally fly a broom on the mast on the way back in to indicate a clean sweep on the trials. Permission to raise a broom up on the mast?
My pleasure to give you permission to
I
hoist the
appreciate
broom.
it.
Starboard halyards? Or...
Starboard halyard.
All right.
It's something about it, once you take it out to sea, the ship really comes to life and it becomes a person unto itself. Starts developing its own personality. And that's a lot. It makes you feel like you were part of something. And when you look at the size of the ship and the way it performed, it really makes you feel great.
This ship changes from being 90,000 tons of steel and piping and cable and electronics to being a city of 3,000 people who operate an airport and who are willing to take this thing to sea and take it in harm's way. It is a truly remarkable event, and it's great to be part of something like that.
You know, we've only been at it for 2 years, and literally we've only been to sea now for a total of 6 days. But we already have a reputation of professional competence, and I feel very good about that.
The very sight of the Harry S. Truman
will summon our best ideals and recall the will and vision of a man who arrived when we needed him most. Some will look at this carrier and see only her massive physical dimensions. I hope most of us will see something even bigger. The living spirit of America. God bless you, and thank you very much.
I shall now read my orders. From Chief of Naval Personnel to Captain Thomas G. Otterbein, United States Navy. Upon commissioning of United States ship Harry S. Truman, CVN 75, report for duty as commanding officer. Admiral Johnson, United States ship Harry S. Truman is in commission, and I assume command.